This video is going to discuss free fall acceleration. The objective is that students will be able to identify and recite equations and facts about falling objects. Let's go ahead and get something out to write with, something to write on, and let's get started. Back in the late 1500s to early 1600s, Galileo conducted experiments concerning falling objects. He discovered that all objects fall at the same rate regardless of mass, assuming there's not much air resistance. So he actually went to the top of the Leaning Tower of Pisa, dropped two objects about the same size but different mass, and they still hit the ground at the same time, so mass really didn't matter. We know this is because of Earth's gravitational field acting on the objects, and Earth's gravitational field doesn't change depending on how much mass something has. This is called the acceleration due to Earth's gravity, and it has a value of 9.81 meters per second squared. The symbol we'll use for gravitational acceleration is g. Since falling objects accelerate due to Earth's gravitational field, we can use the same equations as before to describe their motion. So we're going to use those same equations of constant acceleration that we used in class recently. All four of these. They're on the equation sheet, so you don't have to memorize them. You do have to know what these symbols stand for. VI and VF stand for initial and final velocity, but now they're going to mean vertical velocity instead of horizontal. A is the acceleration, which for vertical stuff is always going to be the acceleration of gravity, which is negative 9.81 meters per second squared. D is the distance, but now it's the vertical distance, or the height. And T is time. Acceleration due to Earth's gravitational field is directed toward the Earth's surface. And typically we use up as the positive direction and down as negative, and that makes the acceleration due to Earth's gravitational field negative 9.81 meters per second squared. So let's say I throw a ball straight up into the air. What is its velocity at the very top of its flight when it reaches its highest point? How fast is it moving? If you said 0 meters per second, you would be correct. This happens because the ball comes to a stop before it comes back down. At that moment, when it reaches that highest point, when its velocity is 0 at the very top of its flight, what's its acceleration? If you said the acceleration would be 0 up there, then that wouldn't make much sense, because if it all of a sudden stopped accelerating, that means gravity turned off. And throwing stuff in the air doesn't turn off gravity. So its acceleration is still that of gravity. It's still negative 9.81 meters per second squared. So no matter where something is flying through the air, its acceleration is always negative 9.81 meters per second squared. Even when its velocity is 0, because that's what makes it come back down. So to recap, we use the same acceleration equations as before to describe falling objects. Objects fall at the same rate regardless of their mass. Remember to take the Edmodo homework quiz on free fall acceleration to receive credit for these notes. And thanks for watching. Make sure you bring your notes with you to class next time to help you with the quiz.